Now we are going to see the type of sets. The first one is empty set or null set. The term empty itself which says that nothing is there. So the definition you see, a set consisting of no element is called the empty set or null set or void set, which is denoted by the letter phi. It's a Greek letter, so we used to use this. Okay, or only set bracket. Okay, children. So this is null set. Example: a is equal to x such that x is an odd integer and divisible by 2. You know that odd integer never divisible by 2. Therefore, a is the empty set. One more example: the set of all integers between 1 and 2. Set of all integers between 1 and 2. So this is equal to empty set. Next is singleton set. Single means you know it's one. A set which has only one element is called a singleton set. See here, all the sets, set bracket 0 and set pi, empty sets. These two are not empty set. These two are singleton set. Each set which has one element. These are the examples for singleton set. Here they mention example. The first one, a is equal to x such that 3 less than x less than 5. X belongs to n, natural number. The natural number between 3 and 5 is only 4. Therefore, this is equal to 4. We have only one number. Therefore, it's a singleton set. The set of all even prime numbers. You know that even prime number is only 2. This is the only even prime number. So these are the examples for singleton set. Next is finite set. A set with finite number of elements is called a finite set. So we should have the definite number of elements, that is known as finite set. Example: the set of family members. You know that family members will be limited. Am I right? So family members, set of family members. Second example: the set of indoor or outdoor games you play. It's also finite. Third one: the set of curricular subjects you learn in school. Particularly in 10th standard, you learn Tamil or language in general, Tamil, English, maths, science, social. Then it's finite number of subjects. Clear, children? Like that, the last one, a is equal to x such that x is a factor of 36. Factor of 36. Just we can recollect what is factor of 36. 1, we can divide 36. 2, 3, 6, 9, 12, 18, 36. These are the factors of 36. This is also finite number. Then an empty set has no elements. Empty set has no elements. So pi is a finite set. It's important. Empty set is also a finite set. Empty set is also a finite set. Next is infinite set. It's just opposite of finite. A set which is not finite is called an infinite set. Example, first one, 5, 10, 15, which will go like that, am I right? 15, then 20, 25, like that. There is no end for that. So this is an example for infinite set. Like that, the second one, the set of all points on a line. This is also infinite. We can't count the points in a line. Okay, children? So then, is the set of natural numbers is finite set. Is the set of natural numbers is finite set. It's not a finite set. No, it's infinite. Yes, children. Next is cardinal number of a set. When a set is finite, so we are defining cardinal number for finite sets. When a set is finite, it is very useful to know how many elements it has. The number of elements in a set is called cardinal number. So just you remember this. Students, cardinal number means number of elements present in a set, which is denoted by n of a, number of elements in a. Okay, children? So we can say that first definition, the empty set has no element. So we can say that n of a is 0. This is the cardinal number. Then are the sets 0 and set pi are empty sets? No. Reason, number of elements is 1. It's singleton set. Okay, children? So singleton set, you know that n of a is equal to 1 always. The finite set, you know, it's finite number of elements. Next is equivalent set. Two finite sets, A and B, are said to be equivalent if they contain the same number of elements. Same number of elements, which is denoted by A equivalent to B. This symbol we are using. Okay, children? We should have same number of elements. That is given in the next line. N of A is equal to N of B. You have to remember that. If A and B are equivalent sets, then N of A is equal to N of B. For example, consider a set A equal to set bracket ball, bat, and B is set history, geography. Both the sets has only 2 elements. N of A is equal to N of B is equal to 2. Therefore, A and B are equivalent sets. So I can write A is equivalent to B. Next is equal sets. Two sets are said to be equal if they contain exactly the same elements. Otherwise, they are said to be unequal. In other words, two sets A and B are said to be equal if every element of A is also an element of B. Second, every element of B is also an element of A. Okay, this is another form of definition. But you can learn two sets are said to be equal if they contain exactly the same elements. That is the definition for equal sets. Example, consider the sets A is equal to 1, 2, 3, 4 and B is equal to set 4, 2, 3, 1. So order is different but the elements are same. Therefore, A and B are said to be equal sets that can be denoted by A is equal to B. Next is universal. The word universal itself, which contains everything. Okay, children? The universal set means is a set which contains all the elements of all the sets under consideration and is usually denoted by U. For example, if we discuss about elements in natural numbers, then the universal set U is natural numbers. U is equal to set x such that x belongs to n. Second, if A is equal to set Earth, Mars, Jupiter, then the universe set U is the planets of solar system. So like this, we used to consider the universal set. Like this, we can consider the universal set. Next is subset. Let A and B be two sets. If every element of A is also an element of B, then A is called a subset of B. We write A contained in or equal to B. That is the symbol for subset. For example, first one, set 1 contained in or equal to set 1, 2, 3. 1 is an element of 1, 2, 3. Therefore, this is a set. Okay, we are putting within the set bracket. So, it's a set. If they are writing, you must know the difference. That is, if I am writing for the first one, 1 dash 1, 2, 3. Now, you have to use only an element. But at the same time, if I am using set bracket 1 dash 1, 2, 3, now you have to write it's a subset. It's a proper subset that we'll discuss later. So we can use this symbol for proper subset. Okay, children. Second example, set 2, 4 is not a subset of set 1, 2, 3. 2 is there but 4 is not there. So it's not a subset. Next is proper subset. Let A and B be two sets. If A is a subset of B and A is not equal to B, is not to be equal. Very clear, children? If A is a subset of B, then what is the meaning of that? All the elements of A are in B and A is not equal to B. It's not equal sets. Then A is called a proper subset of B and we write A contained in B. The equal to sign won't be here. It's contained in B. Okay, children? Subset symbol is this one. Proper subset symbol is this. Example, if A is equal to 1, 2, 5 and B is equal to 1, 2, 3, 4, 5. Here, all the elements of A are in B, but it's not equal. Therefore, A is a proper subset of B. A contained in B. Next is disjoint sets. Disjoint set means, join means it's together. Disjoint, there is no common element. Two sets A and B are said to be disjoint if they do not have common element. Do not have no common element. Okay, children. In other words, if A intersection B is equal to null set, this operations we'll discuss later, then A and B are said to be disjoint. Okay, children? This notation we didn't learn still. This we will learn in the next exercise. Next is power set. The set of all subsets of a set A is called the power set of A. It's denoted by P of A. For example, if A is equal to 2, 3, then find the power set of A. First you have to write all the subsets. See, you must know A is a subset and pi is also a subset of A set. Then you can go for singleton sets 2 and 3. Then two element set, that is 2, 3. Okay, children? So 2, 3 is nothing but A. That already I marked here. So this is 2, 3, the same set. Okay, children? Therefore, the subsets of A are null set, then singleton set, 2 element set. Okay, children? If you are putting all the 4 sets in a set bracket, that is known as power set of A. Clear, children? Then A is equal to, second one, A is equal to set pi and a singleton set which has pi as an element. So while writing here, there are 2 elements are there. Therefore, while writing all the subsets, pi is the first subset. Then I am writing that A set itself. This is A set. Then we have to write the singleton sets. Okay, children? While writing, you have to use all the required set brackets. Okay? This is a typical example. We have to practice this. Next, an important property. If n of A is m, then n of P of A is equal to 2 power m. That is 2 power n of A. This is the formula. Just to remember this. N of A is m means 2 power m. In general, you can learn n of P of A is 2 power n of A. Second one, the number of proper subsets of A is n of P of A minus 1. That is equal to 2 power m minus 1. That is 2 power n of A minus 1. Since you know improper subset is the set itself. Okay, the set itself is known as improper subset. That is one set that you have to delete from the list of power set. Okay, children. So n of P of A minus 1, which gives the number of proper subsets. So they given the note to the side. Important note. Every set has only one improper subset. Now we can discuss exercise number 1.2. First one, find the cardinal numbers of the following sets. Just I am going to discuss directly. In the first subdivision, it's quite easy. It's in roster form. You can count the numbers. Here, n of m is equal to 6. 6 elements are there. Second part, x is equal to 3n plus 2. N belongs to W. N belongs to W. X is less than 15. So you have to calculate it carefully. N belongs to W. So I can start with 0. So I will be getting 0, 0 plus 2. I am getting set 0 plus 2, it's 2. Then 1 I have to substitute. That is 3 into 1 is 3. 3 plus 2, 5. Then 2 you substitute. 3 2s are 6. 6 plus 2 is 8. Then you substitute 3. 3 3s are 9. 9 plus 2 is 11. Then you substitute 4. 3 4s are 12. 12 plus 2 is 14. Then if you are going for 5, 3 5s are 15 plus 2 is 17. But x must be less than 15. So we have to stop with 14. Therefore, it's very clear that this set, that is P set, n of P is equal to 5 elements. So like this, you must know how to do the calculation. Next, Q is equal to set y such that y is equal to 4 by 3n. N belongs to natural numbers. So n starts from 1, 2, 3, etc. But they given one condition, 2 less than 2 we can't include. So we can take only from 3. Okay children? Therefore, you can substitute from 3. 3 in the place of n. That is 4 by 9. Then you substitute 4. 4 we can cancel. It becomes 1 by 3. Next you substitute 5. 4 by 15. So it's very clear that the set Q has only 3 elements. N of Q is equal to 3. Next, the fourth subdivision, x such that x is an integer, x belongs to set. So we can write the set for the fourth one. First I am writing it down. R is equal to, listen carefully, set of all the elements or integers from minus 5 to 4. Right? It's less than 5. So I can't include 5. So it starts from minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. These are the elements. Therefore, from this we can write n of R is equal to 10 elements. Then fifth one. Yes. Leap year. Basically, you must know what is leap year. The year must be divisible by 4. The year must be divisible by 4, but not divisible by 400. Is the definition. Normally, leap year means everyone used to say it's divisible by 4. But there is an additional condition. It's not divisible by 400. Very clear, children? Second condition is not needed for this one. It's not multiple of 400. No need to bother about that. Just you check whether the given years are divisible by 4. By that way, you can conclude it. Okay, children? See here. First one is actually 1882. You just divide by 4. Okay, children? Directly in your mind, you can divide. First problem, just I am explaining it. So this is 4 times 16. So we are getting 2 as balance, 28. 28 7 times, it's 28. The balance is 0. You take 2. 2 is the remainder. So this is not a leap year. 1882 is not a leap year. So leap year means you have to add 2 more. 1884. Next is 1888. 1892. 1896. 1900. Since it's not divisible by 400. Next is 1904. It's between 1906, Therefore, this is the loss possibility. Now you can check the number of elements. You found that we are getting only 6 elements. Second question. Identify the following sets as finite or infinite. So we know that finite means finite number of elements, if not infinite. Okay, children? So first one, the set of all districts in Tamil Nadu. So the first one is finite. The first one, the answer is finite. Now second, the set of all straight lines passing through a point. Through a point, we can draw infinite number of lines. Therefore, this is infinite. Third one, A is equal to set x such that x belongs to set and x is less than 5. What is the meaning of this? This is equal to set. Set means you know that it's from the end of negatives to end of positives. Okay, children, for integers. So we are getting etc. -2, -1, 0, 1, 2, 3, 4. 5 we can't take. Here all negative integers are included. Therefore, it's very clear that this is infinite. Next, fourth one. Fourth one, x square minus 5x plus 6 equal to 0. We have to factorize this. We'll get, that is, x square minus 5x plus 6 equal to, we are getting x minus 2 into x minus 3 equal to 0. Therefore, we are getting x is equal to 2, 3. Are you clear, children? Therefore, we are getting this is equal to 2, 3. Therefore, the fourth one, it's finite. Clear, students?